In this video we're going to use the sine rule to find a missing angle. If you haven't already watched the previous video on the sine rule and how to find a missing side, that's the place to start. Watch that video first and then come back to this one. Okay, so in the last video we set up a triangle. It doesn't have to be a right angle triangle because the sine rule and the cosine rule work with non-right angled triangles. And we labelled the sides using the convention that we've got here. So capital A for angle and little a for the opposite side. Capital B for an angle, little b for the opposite side. Capital C for an angle, little c for the opposite side. We stick with that convention all the way through. And we introduced the sine rule and said it was A over sine A is exactly the same as B over sine B, and that's exactly the same as C over sine C. Now, if you're finding a missing angle, it actually helps us if we flip that over. That whole fraction can be flipped over to write it like this. So we would start with this sine A over A equals sine B over B equals to sine C over C. That just speeds things up a bit if we start with that as our sine rule. Right, so let's have a look and see if we can use that to solve a problem. So here we've got another non-right angle triangle. We're trying to find this angle here, which is x, and the length of this side is 12, the length of this side is 15, and this angle down here is 40 degrees. So let's start by labelling that up. This is the angle that we're trying to find, is x, so let's call that A. That will make life a little bit easier for us. So the opposite side is little a, and let's call this angle down here that we've got B. So the opposite side is little b, and then that leaves angle C and side C. So little c and big C don't actually get involved in this problem at all because it's an angle that we don't know and a side that we don't know, and we don't want to find either of those things out. So we can just use the bits of the sine rule that we're interested in. Let's have sine A over A equals sine B over B. If we put in the information that we know, angle A is x, so that's sine x now, and the opposite side is 15. Angle B is 40 degrees, so that's sine 40, and opposite side of that is 12. Okay, so now we've got this equation that we need to try and solve, and we need to try and get x on its own. First thing we can do is multiply both sides by 15 and get rid of that 15 on the bottom of the fraction there. So that would give us sine x equals 15 sine 40 over 12. And probably at this stage the best thing to do is to put all of that right hand side into a calculator and work it out. So type in 15 sine 40 and divide by 12. If you do that, you should get that sine x equals 0.803,484,512 and so on. Now it's really important that you keep that in your calculator memory. You can use the answer button if you want to, but make sure you've got that as accurate as you possibly can for the next step. So the final thing is to get x now, and we're going to get rid of that sine that's on the left hand side, and to do that we need to take arc sine. So we get x equals arc sine, or sine to the minus 1, that number 803,484,512. Keep it as accurate as you can. Use the answer function in your calculator if you can, and if you work that out you get x equals 53.5 degrees to 3 significant figures. That's our final answer.